So I was just wondering about squares. If you square two numbers and add them together, in some cases you get the square of a third number, which is an integer. But how close are you to an integer? So let's calculate a big pixel thing of that. Well, thanks for watching, everybody. I seem to have answered the question. Let's have a quick look at the final picture and see what it tells us. So after hacking the code around a bit, I thought for a while the white squares are where x squared plus y squared square rooted equals the square root of an integer. It only works for squares. That was Fermat's last theorem. Here are cubes. With a cube root, you never get a white dot. You never get a cube of one number plus the cube of another cube rooted exactly working to an integer. It looks like if you go along this axis, though, as you creep along, the lighter it gets, the closer you're getting to an integer. It looks like as you creep along, it does do. For a while I had the code wrong. It looked like it was they just appeared out of the black. But it looks like if you creep along, you're getting close. Keep going and you'll get closer and closer. And this line down the middle is interesting. There seem to be squares sort of on the diagonal that work. What else is interesting? This pattern is probably, again, a bit like the prime numbers. I think it would drive you mad if you tried to actually unpick this and understand it. So yeah, you've got to ask these little mathematical questions. Hope you enjoyed that, and I'll see you next time on the In the Loop.